Hey everybody, welcome back. Today we're going to be talking about 2.8. It is the last lesson in chapter 2. We're going to be solving two-step equations today. We've talked about one-step equations, but today it's two steps. So guess how many steps you get to do? 2! Alright, we're going to get started. So, let's start with a few warm-ups. Alright, so here you go. There are 4 warm-ups. These are one-step equations. Remember, inverse operations the entire time. So what I want you to do is I want you to pause now and get these 4 done. Pause and go. Alright, so if we look at this, we have x plus 12 is equal to 35. So I'm just going to write it up here so you can see my work. Again, make sure you're showing your work on this entire problem, because it is very important. I want to see that thinking process. So when you do this, what do you do to that 12 to get rid of it? Well, it's adding in the problem, so we are going to subtract, and we get x is equal to 23. All right, very first one, 23. Number 2, we have 8x equals 120. What do you do to get rid of that 8? Inverse operations. We're going to divide by 8 on both sides. So when you take 120 divided by 8, x is equal to 15. 15. Number 3, second to last one, we have y over 9 is equal to 63. What is happening between the numerator and the denominator? Division. How do we solve? Multiplication. Multiply by 9 on both sides. So when you take 63 and multiply by 9, you get y equals 567. 567. Last one, number 4. Again, negative 34 equals y plus 56. It doesn't change our thinking. Right? So when we do this inverse operations, not arbitrations, operations, you subtract by 56, and when you do that, remember, negative 34 minus 56, if you rewrite it and make it look a little easier, add its opposite, you get a negative 90. Negative 90 for your answer. All right? So those were our 4 warm-ups. Today, let's get started on two-step equations. All right, two-step equations. We're going to be solving. All right, so when you look at this, it says sometimes more than one inverse operation is needed to solve an equation. Before solving, ask yourself, what is being done to the variable, and in what order? Okay, then we work backward to undo the entire operations. We undo the order of operations, go backwards. Just like we take inverse operations to undo the addition or subtraction, we have to go backwards in the problem to undo the operation. What I want you to do is I want you to pause right now and I want you to write this down, just so you can see how we do a word problem right off the bat here. So this is your word problem word problem in the front instead of in the back. So pause now, write this down. You don't need to write down the what we know and what do we need to find, because we can go over that. All right, so pause now, write this down. All right, so it says the mechanic's bill to repair Mr. Wong's car was $643. Wow, I'm glad I'm not Mr. Wong. It's a good thing I'm Mr. Sheeman. Oh, high five. Good job. Okay, the mechanic charges $50 an hour for labor, and the parts were used cost at $443. How many hours did the mechanic work? Well, what do we know? We know the total cost. We know the total cost is going to be how much? $643. We know it costs $643. We also know how much were the parts. Okay? Well, we know the parts. The parts were $443 altogether. We know how much the mechanic charges for labor. Labor is $50 per hour. Okay, I'm going to put per hour. Now, what we need to find is how many hours did the mechanic find. Okay, so when we do this problem, you have to think about, okay, what are we trying to find? We're trying to find hours. Okay, if I don't know something in math, what do I do when I don't know something? I plug in a variable. Okay, so when I don't know something, I plug in a variable. So what do I not know? Well, I don't know how many hours this mechanic is working on. Okay, what we do know is the entire thing, no matter what, between parts and labor, it's going to cost $643. Now, my question to you is going to be, what happens if I take the used parts, how much they cost, and the mechanics, how much he charges for an hour? Is that going to go up or is it going to go down? Well, if I charge 1 hour, or the mechanic charges 1 hour, he's going to go up $50 every single hour. So after 2 hours, it's going to go up $100. After 3 hours, $150. We know it's going to be adding here, all right? Adding the entire time because we're moving up in price. Every hour this mechanic spends repairing the car is costing more money. So what is the minimum the person is going to charge, or the person is going to spend? Well, the minimum is going to be this parts, because he needs to get the car fixed. Without the parts, you can't really fix the car. So the minimum is going to be $443. We know that's the minimum. Now, for $50 an hour, we are going to write something like this, 50x, because we do not know how many hours they are spending. We need to figure out how many hours, and X stands for hours, okay, because we don't know. All right, we don't know how many hours. We just know that after the first hour, it's another $50. What if he didn't spend he got done in 15 minutes, which would be amazing, by the way, but he would get done in 15 minutes. Did he spend an hour? No, he didn't have to pay the $50. Okay, so our equation looks like this. Just replace the H with X, same exact thing. So now we have to figure out what is happening to this equation. So if you read this, 443 plus 50 times H equals 643. What we want to do is we want to get H all by itself. And we have to do the inverse operations of what's happening. At the same time, we have to go backwards in the order of operations. So order of operations state, multiply and divide, then add and subtract. But because we go backwards in the order of operations, what we have to do is we have to add or subtract first. So what happens? We want to get rid of this 443. How do we do that? We subtract minus 443. Okay, so what's left is I now have 50H is equal to 643 minus 443 is 200. So I wanted to get rid of that 443 first, because you add or subtract when we are undoing an equation. Add or subtract first, then multiply or divide. What are we going to do in this next step? We're going to divide by 50. Remember, inverse operations. The entire time we're taking inverse operations. We are subtracting 443 right off the bat because that's how we get that equal to 0 on the left side. Then we divide by 50 because that's how we get it equal to 1. And 200 divided by 50 is 40. Now, sorry, not 40. 40 hours. Woo. Don't forget about our label of 4 hours. You go backwards through this in the entire equation. Okay? Undo the entire equation to solve. All right? Undo the equation. All right. Here we go. We're going to do several of these problems. Okay. So as I look at this, we have n over 3 plus 7 equals 22. Okay, when we do this, we're trying to figure out what is happening to the variable. Well, first it's being divided and then it's being added. Okay, so if you looked at this, you would actually have to divide first, then add. However, backwards operations state, and you should be still listening to this, I don't want you to pause, okay, state that we had to subtract 7, get rid of the 7 first. We want to isolate. We want to get this variable all by itself. Isolate the variable. Okay? And what's happening to the variable? So you subtract on both sides. Get rid of that 7. Okay? So you have n over 3 is equal to 15. We went backwards in the order of operations by subtracting first. Okay. Now, what's happening to the variable with the n over 3? Well, it's being divided, so we need to multiply each equation. N is equal to 45. You undo the entire equation as we are working through this. We got rid of this 7 by subtracting. On inverse operations, subtraction, that's how you get rid of it. Okay, don't forget inverse operations this entire time. Okay? Okay. All right, there's going to be several problems today. What I want you to do is I want you to pause the video right now and I want you to try this problem. Remember, think about what we need to get rid of by using inverse operations, then take that second step, again, inverse operations. I want you to make sure that you are writing down the work. Show your work. It's very, very important. So pause, try this problem. All right, so we got n over 4 plus 8 equals 18. Okay, so what do you have to do to get rid of this, to get n all by itself? We want to isolate the variable. Isolate, get it all by itself. How do we get rid of that? Well, subtract. Get rid of this 8. Get rid of it. We don't like it. It's ugly. Get it out of there. Okay, subtract 8 on both sides, and we're left with n over 4 equals 10. Inverse operations. Now, I want you to think in your head what's happening. Now that you thought about it, I want you to tell the person next to you or the person that's closest to you. So if there's a person in the living room that's close to you, run out there, tell them exactly what's happening. I'll sit here and wait. You should be getting up right now. Don't get up. Or get up and go tell somebody. I hope you're not still sitting there. Are you still waiting? All right, here we go. So what you have to do is you have to multiply. Multiply this 4. Multiply by 4. And then get your answer of 40. Why did I multiply? Because this problem is dividing. Exactly what you just told somebody else. You're dividing in the problem, and you have to multiply. All right? All right. Okay, new problem, same idea. Pause, give it a shot. All right, so when we do this, we have x over a negative 9 minus 3 equals 10. Equals 10. What do we get rid of first? The 3. How do you get rid of the 3? By adding. Why do we add? Inverse operations. I am hoping you are remembering that because I'm saying it a lot and you're sick of me saying that because I've said it so much. But just remember, I'm going to keep saying it. I'm going to keep saying it, keep saying it, keep saying it. Because inverse operations are important. That's how you solve equations. Inverse operations. Inverse operations. Do, 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 do. All right. So now, what is happening between the x and the negative 9? Division. So what do we have to do? Multiplication. Yes, multiplication. Multiply. Multiply this bad 13, and you get an answer of what? What is 13 times a negative 9? Negativo 117. Don't forget, negative times a positive is a negative. Don't ever forget that. All right? Here we go. Next problem. We're doing a lot of these problems, right? This one's a little bit different. I want you to take the exact same process, though, and think. What do we have to do? Don't change anything. Don't change anything with the numbers. Okay, just because the numbers might be looking a little different, inverse operations, get rid of the things you need to get rid of first. So I want you to pause now, give it a shot. All right, so we have 7y plus 25 equals 24. Now, What do we want to get rid of first? Get rid of this 25. Go backwards in the order of operations. Subtract by 25 first. Subtract by 25. Okay, so now if I take 24 minus 25, you get -1. I hope you didn't get 49, just because they look like numbers that you can easily get rid of by dividing now. Okay, go through the operations. Watch those parts. Okay, so I'm going to divide by 7 on both sides. Why do I divide by 7? Because multiplication is happening here. They're grouped together. That's multiplication. Undo them. Okay, so you get y is equal to, and you can leave it as a fraction of -1/7. Leave it as a fraction and you are perfectly fine. If you took 1 divided by -1 divided by 7, well, don't change it into a decimal. Leave it as a fraction. Okay? All right. Next. This is the last problem we are going to do today. Just think, inverse operations. What's happening? Don't let the numbers fool you or change your mind. Okay, inverse operations. You know how to come up with integer work, but just remember inverse operations. Operations day inverse. Inverse operations. Pause now. Give this one a shot. All right, here we go. We have 3n plus 3 equals -21. We want to get n all by itself. What do we have to get rid of? This adding first. We get rid of the adding first because it's being added to 3 times n. Remember, we're going backwards in the order of operations. We're going to subtract here. Okay, now if I look at this, oop, not x. I'm changing up the variable mid-problem. You can't do that, Mr. Sheeman. Okay, I take -21 minus 3. Notice how I rewrote this here. And I rewrote it so I can see I need to add its opposite. And when I do that, because that's one of the tougher problems to remember, that we have to add its opposite, and we're going to actually take -21 plus a -3 to get a -24. Not -18, we get our -24. How do you get rid of the 3? By divide. Man, we're doing a lot of threes in this problem. Subtract 3 first, divide by 3 second, take -24 divided by 3, it is -8. Why is it negative? Negative divided by positive is negative. I hope you were saying that. All right. So our answer is -8. Remember, inverse operations. Unbelievably important. Star it. Inverse operations. Underline it. Bold it. Read this right before you go to bed tonight so you memorize it. Dream about inverse operations, because dreaming about math is just wonderful. All right? So have a great day. I will see you later. Bye.